Hey class, we're going to go ahead and get into part 4 of solving and graphing inequalities. Solving inequalities is very similar to solving equations with one exception. Well, one or two exceptions, okay? I'm going to go ahead and erase it. We're going to go ahead and get started. This is from part 3. Here we go. All right, so now we're going to solve inequalities. Okay, solve inequalities, all right? Here we go. This is our first example. Example 1. Example 1, we have x plus 3. Oh, no. X plus 3 less than or equal. Let's do greater than equal. Greater than or equal to 5. There we go. All right, that's good. X plus 3 greater than or equal to 5. Okay? Now, we treat this inequality symbol just like it was an equal sign. Okay? Just like as if we were solving an equation. Now, for inequalities, you don't have to check, please. You don't have to check, right? You don't have to check, but you do have to draw or graph the inequality solution, okay, on the number line, just like we did before, okay? So now we look at the same way we talked about equation. What is being done to the variable? What operation is this? This is addition. What is the opposite of addition? Subtraction. So we're going to subtract what? 3. And whatever you do to the left, you also have to do to the right. Good. We're going to subtract 3. 3 minus 3, 0. X comes down. Inequality symbol comes down. 5 minus 3, we get 2. And so we have now gotten the inequality solution. X greater than or equal to 2. Now, what did we do before that we're going to have to do here on a number line? Starts with a G. Starts with a G. Ends with graphing. Graphing, right? We're going to graph this. Now, where do we start? What number is this? 2. That means we're going to start here at the number 2. We got 3. We got 4. We got 5. We got 1, 0, negative 1. Now, first things first. What symbol do we have? What symbol? Greater than or equal to. Now, what does that tell us? Are we going to have an open circle or closed? Open or closed? Look at your notes. Greater than or equal. Open or closed circle? Type in the chat. Closed. We're going to have a closed circle on the number 2. That means we are going to include the number 2. If we plug 2 here, 2 is greater than or equal to 2. It's equal. Yes, we're going to include it. Now, which way is our arrow pointing? Remember, we can use that way, that kind of thinking to help us graph this. It is pointing to the right. Therefore, we're going to shade to the right. We're going to shade. That means it continues on forever. Remember, this is X. Is everything that is greater than or equal to 2. Everything greater than or equal to 2 is in that direction and on the 2 itself. And so we are done here. We got our inequality, which is X. I'm going to erase this a little bit. Again, you can keep that there. It's fine. X is everything that is greater than or equal to 2. To graph it, we have to think about open or closed circle. I'm going to write it over here. Closed circle, because we include the 2. 2, if we substitute 2 here, is 2 greater than or equal to 2? Yes. Is 3 greater than or equal to 2? Yes. Is 4 greater than or equal to 2? Yes. And 5 and 6 and forever, infinity, is greater than or equal to 2? Yes. So that is why we have that number line solution. We're going to go ahead and move on to our example number 2. Make sure you have that written down. I'm about to erase it. Make sure you have this written down. All right, let's move on. All right, example number 2. Example number 2 is x minus 7 less than equal to 12. Okay, less than equal to 12. Now again, we treat this just like it's an equation. The exceptions are the first exception that I told you about is drawing the number line solution, and you don't have to check. That's the first exception. That's how it's different from an equation. The next one, we're going to get to that in a little bit. Okay, we're going to get that in a little while. All right, what is being done to the variable? What operation? Subtraction, right? Subtraction. Right now, subtraction is happening. Now, what are we subtracting? 7. Subtracting 7. What is the opposite of subtracting 7? The opposite of subtracting 7. Adding 7, right? So we're going to add 7 to the left. And whenever we do to the left, we also have to do to the right. Okay, we're going to add 7 here as well. Negative 7 plus 7, right? Owe $7, you pay $7 back. Or move to the left 7, move back right 7. What are you going to be at? Negative 7 plus 7. What are you going to get? 0, right? 0. And so x plus 0 is just x. Less than equal sign comes down as well. What is 12 plus 7? 19. So we end up with this inequality right here. We still have to draw or graph the inequality solution. We still have to do that, okay? And we're going to go ahead and do that now. Now, where do we start? What number is that? 19. That's where we're going to start. Okay, 19's here, then 20, 21, 22, 23, and then we got 18, 17, 16, yada, 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 right? We're going to keep going, right? Now, look at our symbol. What symbol do we have? Less than or equal to. Now, is less than or equal to, does that tell us an open circle or closed circle? Closed, right? It's a closed circle on the number 19. Because 19, if we substitute it here, is 19 less than or equal to 19? Yeah, it's equal to 19, so we can include it. Now, which way is it pointing? Is it pointing to the left or is it pointing to the right? The arrow is pointing to the left. So that means we're going to shade left. Also, the way to think about it, right, in terms of trying to understand what's happening here, if you substitute 18 here, is 18 less than or equal to 19? Yes. Is 17, we substitute 17 here, 17 less than or equal to, yes. Is 16 less than or equal to 19? Yes. Now, look over here, 20. Is 20 less than or equal to 19? Ask yourself that. Is 20, if you looked at 20, is 20 less than or equal to 19? Yes or no? I'm sorry, not yes or no. Well, yeah, that is a yes or no. Is 20 less than or equal to 19? The answer is no. It is not less than or equal to 19. That's why it's not shaded that way. That is why we're not shading that way. Because this is not, none of these numbers over here to the right give us a true statement. And that's what a solution is you get a true statement, okay? And so this is not true at all. So that's why we shade to the left. All right, so we're gonna go ahead and move on to example 3 and 4, the next video. Thanks for watching.